Okay, so talking about simple harmonic motion. So an object whose position relative to an equilibrium position at time t can be described by either y equals a sine of omega t or y equals a cosine of omega t is said to be in simple harmonic motion. So if you look at these equations, it looks just like the others that we looked at. The difference is instead of x, they put a t, and instead of b, they're using omega. Otherwise, it's exactly the same. And so our amplitude is still that absolute value of a. Our period is 2 pi over omega, because remember that's in the place of b. But the thing that's different is it tells us about it can have frequency. And the frequency is the reciprocal of the period, which means that it is omega over 2 pi, and it gives us the number of cycles completed per unit of time. So, for example 11, it says suppose that a ball attached to a string is pulled down 6 inches and released, and the resulting simple harmonic motion has a period of 8 seconds. Write an equation for the ball's simple harmonic motion. Alright, so I'm going to graph this real quick here. Alright, so we've got this ball that attached to a spring, and it's going to be pulled down 6 inches and then released. So it's going to come down here 6 inches, and we're going to release it, and it's going to go up. And, of course, it's got to come back down. So since it goes down 6 inches, it's also going to go up 6 inches. And it tells us that it has a period of 8 seconds. So when it comes back down to where the -6 is, that's going to be at 8 seconds. And it wants us to write the equation. So the first thing we need to do is we need to decide, are we going to use sine or are we going to use cosine? Well, you're going to use sine if it starts in the middle. So if it starts at the center of the graph and goes up. Well, obviously this one doesn't start in the middle, so we're not going to use sine. But now I wanted to point out on that though, we said and it goes up. Well, if it starts in the middle and it goes down, you're still going to use sine, but you're going to use negative sine instead. For cosine, it starts at the top. Well, if you look at this graph, it doesn't start at the top, it starts at the bottom. So what would make it start at the bottom if it was a negative cosine? So we're actually going to use cosine, we're just going to make it negative. So we know our equation is going to be y equals negative some value a cosine some value omega, and then our t. So remember, a is your amplitude, so it is your maximum minus your minimum divided by 2. And so we find it's 6. So my equation is going to be y equals -6 cosine, and then omega is found because we know that the period is equal to 2 pi over omega. Well, my period here is 8, so that's equal to 2 pi over omega. Multiply both sides by omega. So I'm just going to come over here. So we got 8 times omega equals 2 pi divided by the 8. And we find that omega is equal to pi over 4. And so we're going to plug pi over 4 in for our omega, and there is our equation.